Alright, we've finally gotten the main out of the way, and now we can start to learn how to program. So before we start, I'd like to ask you, why do you think we program? Well, it turns out that computers today aren't that smart. Although people are saying that there's going to be singularity soon and the AI is going to wipe us out, it turns out that mostly computers aren't that smart. And what they do is really just follow instructions. And not just that, they follow instructions precisely. So in order to do cool stuff, right, we need to somehow tell the computer exactly what it is to do. So programming is really communicating this computation process, okay, to a computer. And I like to highlight that the goal here is not to write code that a computer can understand, but also to write code that humans can understand. So before we start, why would you choose to teach in Python? Well, there are many good reasons. First is that it's a kind of a powerful open source language, okay, and to me, the most important reason is that it has a very clear and readable syntax, okay. It also supports object-oriented programming. It expresses code very well, okay, and most importantly, it's very popular and very useful. So there are many libraries out there, and also many of you will be majors in, say, math or statistics or maybe business analytics, right? And for these classes, right, the Python is very useful because it can be used to do data processing. So for me, as I mentioned, the most important reason why Python is a good language is because it's simple, right? And we'll also be learning C later on in this class, and the question is why? Well, it turns out this is a special request by the engineering faculty because C is used for low-level programming of embedded devices. But the focus of this class is not on C, but on programming methodology, which means that these are concepts that are sort of common across any language, all right? So the C parts are mostly just syntax. Okay, so it turns out that I have this view that it is futile to teach a language because when I was young, and that's 20 years ago, when I first started learning programming, it was C. And back then, you have one new language every 10 years. Today, it feels like there's one new language every 10 days. So what we teach will probably not be the same in 10 years, 15 years. So the point is not so much to teach a language, right, but to teach the concepts that will be common, that will be invariant, even as languages come and go. So the high-level idea, okay, in this class is to teach you this concept known as computational thinking. To begin, let's talk about the elements of programming. Okay, the first element are primitives. First, we have numbers. For example, 4, 7 over 2, 428.3, right? So these are numbers, they are primitives. And next, your operators. This is plus, minus, times, divide, right? And we can also symbols. For example, a, pi, and mu, right? So these are the primitive elements that are in Python. Okay, next, we need to have some means of combination. Now in Python, it's very simple. For example, you have 5 plus 3. That gives you 8, right? So what you do is you just stick the symbol right in the middle of two elements and it combines them. Now, if you need to combine more than two elements, what you can do is that you can use parentheses, right? Just brackets over here. Okay, so this is obviously 8. This is 6. Answer is 2. We also need a means of abstraction, which means that we need to be able to somehow handle abstract concepts. Let's take a look at an example. Let's say 7 plus 6, this will be 13. Right, and if you say that a equals 3, a plus 6 will be, well, 9. What happens here is that a, right, is set to be 3. So when you do a plus 6, this a is actually 3, right? So a plus 6 is the same as 3 plus 6, so it's 9. What you've seen here is an instance of naming. So the idea is that you have these variables, which are like labels, right? And they can be used to store values, okay? So these variable names can start from a to z, okay, lowercase, or they can be higher case a to z, or they can start with underscore, right? And they should contain only alphanumeric characters or underscore, and they're case sensitive. That means that Yan Li is not the same as Yan Li, okay, because this is capitalized and this is not, right? So these two are two different variables. They are not the same. Okay. In addition, you need to avoid certain reserved keywords, for example, like if, okay, you will learn about these keywords as we go along. Just avoid them. If you use keywords, you get in trouble and you can see. So it's not a real problem. All right, and pattern convention, this convention is use lowercase letters separated by the underscore. So for example, count change is count underscore change. Now, if you don't use this convention and basically use some random mix without this underscore, you can also use them as variables, but it's just not so pretty, right? And the general idea of variables is that they refer to some memory address. Now let's look at this concept called types. So the different types of variable, for example, ints are whole numbers. They are like this. They can be positive, can be negative. So 8, 8, 45, 1, 2, 3, 4. These are integers. You can have floats. Floats are like 2.3, 3.14, and so forth. Okay, so basically these are decimal numbers, right? And the basic thing to understand is that because suppose you have some kind of rational number, obviously it's not possible to keep track of all the digits. So floats have a certain fixed amount of storage capacity, and because that, it leads to some truncation and some representation errors. Alright, and bool will be two types, true and false. So bool stands for boolean, which are just true and false values. Okay, so the key thing about variable types is that different types will take up different amount of storage space, and that's basically the types that determine how a certain variable object is stored in memory. Okay, there's also strings. Strings are just a bunch of characters. Okay, so this is a bunch of string and this is a string. And strings are delimited by this apostrophe, either double or single. Doesn't matter which you use, they are the same. You just make sure you use the same on both sides. So either both double or both single, not one double, one single. Now then there's a none, which is a none type, which means that there's nothing. Okay. So okay. Given a variable or some object, you can decide the type by using this type operation. So for example, you do type 1, 2, 3, answer will be integer, okay, because this is an int. Alright. Now next if you try 1, 2, 3, but now there's this apostrophe here, means this thing will be a string, right? Now if you do type none, then answer is none. Okay, you can convert the type of objects from one to another by using the kind of the type keyword, right? So for example, str, okay, 1, 2, 3, this 1, 2, 3 string, right? Now why would you want to convert this type? Well, at this point I won't discuss this, but after a while, you know, when we start doing real problems, you will eventually see the application. Just for now, just keep in mind that you can convert these different types. So float, this thing will be actually 45.2, okay, string becomes a floating point number 45.2 over here. Okay, in 23.8. Now what happens is that this is actually a decimal number, right? Int will be this part. So what happens when you convert it is that it gets truncated. Okay, this 0.8 is actually lost. Now if you do int this string, answer will be, well, error, because I also don't know how to convert. Okay, now next we can do assignments, which means you want to name things, right? Name objects. So let's take a look. If ABC is 28, okay, and my string is, this is a string, what happens actually in the computer is that in the memory, there is this variables ABC and my string, okay, and essentially these two variables point to some addresses, ID1 and ID2. Okay, so ID1 points to this object 28, ID2 points to another object, which is this string. So the key to understand is that variables correspond to these arrows. Okay, this is called pointer, right? And this is not really a box. Okay, think of variables as a pointer and not a box. So the variables is the arrow that points to something, right? And that's basically how it works. Alright, suppose you do x, y equals 1, 2. What happens is that you are actually doing this. Okay, you are assigning 1 to x and y to 2 simultaneously. So in Python, if you separate these variables by comments, you can actually do this assignments simultaneously. Okay, and this obviously creates this two new variables in memory, x and y, which point to 1 and 2 respectively. Alright, and as you saw earlier, obviously we have arithmetic operations. There's the plus, there's minus, there's a star, which is times, there's divide. Okay, what is star star? Star star, it turns out, is power. Okay, slash slash is actually division, but the integer division, so it's actually a quotient. And when you do integer division or quotient, there's also the remainder. So percentage is the remainder. So let's take a look at some examples. Let's say a equals 2 times 3. The answer is 6, obviously. If you do 2 star star 3, this is 2 to the power 3. Answer will be 8, right? Now, if you do 11 divided by 3, obviously you get 3 by something, 3.6, something. Okay, if you do 11 slash slash 3, so this is actually quotient, right? So you know answer will be 3 because the integer parts, and if you find the remainder, that will be 2. Okay. Now, next thing I want to briefly talk about are these true values. So statements can either be true or false. Okay, for example, 2 is bigger than 1 is actually true. It's a true statement, right? 5 is smaller than 3 is not a true statement, it's a false statement, so it's false. Okay, and you can actually compare things in Python. So this is obviously your bigger than equals, smaller than equals, and this is not equals. So this thing is not, right? The exclamation mark. Now, so do 1 less than equal 10, answer obviously is true. Okay, if 5 bigger than 13, answer will be false. Okay, 5 less than equals 5, answer will be true, right? And if you do 2 not equals 3, answer will be true. 1 equals to 1. Okay, now this one looks the same, but it's not because this one is a string, right? This is an integer, so answer will be false. Now, if you compare two false values, it turns out they are actually the same, so it's true. Alright, let me just summarize. There are 3 basic operations. There's a NOT operation. So if A is true, not A is false. If A is false, not A is true. So what NOT does over here is that it inverts the value. Then there's an OR operator. Okay, the OR operator is true if A or B are true. If either A or B are true, alright, and false only if both A and B are false. So it's here, okay, where this is false and this is false. Then there's the AND operator. Okay, the AND operator is true only if both A and B are true. So if A, okay, is true and B is true, then this is true. If not, then the rest are all false. Okay, so you need to understand these basic truth tables. Python uses the keywords true and false to represent true and false respectively, right? And in Python 3x, so Python 2 is a bit different. True and false are always equal to 1 and 0, okay? And anything that's not 0 or empty will also be considered true. Now, what is empty? Later on in the semester, you learn about different data structures like lists and sets, and they can be empty. For now, just ignore. Okay, just know that if it's not 0, then it's actually false. Okay, so the 3 operators that you can actually run in Python: the OR, the AND, and the NOT. Right, so you do true or false. Okay, answer will be true, right? Because once you have a true, the OR doesn't matter what's behind, it's always true. Now, if you do true and 0, the answer will be false, right? Because yeah, it's supposed to be false because it both be true in order for this to be true. It turns out answer will be 0 because what it does is that it sees true and then ignores this part and then it goes back and returns this number. But because 0 is equivalent to false anyway, this is correct. Okay, not 0 will return true, obviously, because 0 is considered false. Alright, let's talk about strings. So let's say you have S as BA, the string BA. If T is CK, then S plus T will be back, right? So you just concatenate the two strings. Next, okay, suppose you do T equals to S plus NA squared. Okay, what happens? So T will be banana, right? Because it's B, your S is BA, right? And there's 2 more NA after that, so you'll be banana. So you can also sort of multiply strings this way, okay? You can concatenate copies of strings this way. Next, if you try Z is T, the answer will be false. But you're checking whether or not this character is inside T. Banana doesn't contain Z, so obviously it's not true. Okay, let's say you try banat bigger than T. Is this true or false? Well, it turns out answer is true. Okay, why is that so? Well, it turns out that for strings, you can use comparison operators, greater than, less than, and the comparison is done according to dictionary order. So if a string appears before another string, then it's considered smaller, right? Because it's in the dictionary, it comes before that. So banana comes before banana B. So after that, so because of that, this thing is bigger than banana, right? Now, if you do banan, okay, then banana it comes before after banana, it comes before banana. So this is actually true, right? On the other hand, we check whether C is less than T. The answer will be false because C, even though it's just one character long, okay, it comes after banana in the dictionary. Okay, let's talk about string slicing. It turns out that a string is a sequence of characters. Okay, so we can also index a string, okay, using an integer. So, for example, if S is A, B, C, D, then S0 will be A. Okay, so this is the first character, okay, and it's S0. Now, so S2 obviously then would be, if this is 0, okay, this must be 1, this must be 2, this must be 3, so C must be S2. Okay, very simple. So the key thing to understand is that computer scientists like us, we start from 0 when we count, alright? So keep that in mind. Now, you can also slice out a whole bunch of letters instead of just indexing one letter. So let's take a look at how this is done. Suppose A is A, B, C, D, E, F, 6 characters. Suppose to do S0:2. Okay, so it turns out 0 is the start index, 2 is the stop index, right? So 0 is A, so A, then stop index 2 is C. So it stops AB, which means that this stop index is the index that is after the end. Okay, so you do A1:2, you start from B, which is which is at position 1, right? So you end before C, so you get 2. If you do S:2, what do you get? You get the same as S0:2, you get AB, right? If this start is missing, then it starts from the beginning. If stops missing, it stops at the end. Suppose you do S153, then now the three different parameters. The third one is a step. Okay, so what this means is that you start from the 1 index, which is a B, then you jump by 3, so 1, 2, 3, you get E, and this is okay, and you stop at 5, which is the end, so it's fine. You're supposed to do S:2, that means that start is the beginning, end is the end, and every 2 characters. So you start with A, and then you jump 2 C, jump 2 you get E, so answer is ACE. Okay, just keep in mind that this stop is non-inclusive. That means it doesn't include the index, right? It stopped just 1 before that. Okay, and this is a little bit obscure at this point, but keep in mind that slicing returns you a new string, right? So that means it's not the old string, it's a new object altogether. Okay, so far we've seen only single line expressions. Let's take a look at multi-line expressions. So the basic form that we want to discuss is this thing called if. Okay, if expression, right? Something. So the idea here is to say that if something is true to something, example, let's say A is 3. If A is greater than 0, print A greater than 0. What happens? You actually print A greater than 0. Okay, because this part, okay, is true because A is 3, so this particular expression here is true, and this expression is true, you will do these operations. Okay. Next. Okay. One thing to keep in mind is that there's this indentation here, okay, which is important. So Python requires indentation to mark different segments of code. Okay, so indentation matters, and the key thing to understand that this is a very Python thing, right? Different languages have different ways of marking of delimiting the code. Many use parentheses, either round or curly. Okay, but Python uses just the indentation. Okay, so you can have another form of this if else. Okay, so the idea here is that if this expression is true, do this. Otherwise, you do this task. Okay, example, if A is -3, if A bigger than 0, do this. If else, do this. So basically, you will come in here, you evaluate this expression, you'll be true or false. You'll be false, right? Because A is -3, so A is so -3 is obviously smaller than 0, so A -3 bigger than 0 is false. So this is ignored, right? And you will print this thing, so you get this. All right. Okay, keep in mind that there's this indentation for these segments of code over here. Now, you can also have more expressions. So, for example, if you have if expression 1, else if expression 2, and so forth, right? So what this means is that if expression 1 is true, you do this thing. If expression 2 is true, you do this thing. Otherwise, you do this part. Okay. So if any of these expressions earlier on are true, then the rest of the statements here will be ignored. Now let's take a look. If A is -3, if A is greater than 0, print this, else this, else this. Okay, what happens? So A equals -3, you try this part. Okay, this will be false, right? So ignore. A is 0, it's false, ignore. So you print A less than 0. Now, as it turns out, you can have more else if statements. For example, in this case, that 2. Okay, so you have more expressions. So let's take a look at this example. So here A is 4. Okay, and there are now four set of expressions, right? So first you can check whether A is greater than 0. So A is 4, answer is true, so it prints this. Now it turns out that over here, there's one expression that matches this completely. But because over here, okay, this expression is true, so this is very done. Everything else is ignored. So answer will be A greater than 0. Alright, so you have just learned Python in 15 minutes. How cool is that? Yeah, that's basically all you have for this week. Well, this is the first week. So I don't want all of you to be too stressed. I want all of you to spend time like playing around with the idle, installing things, getting things to work mostly. So we'll start our real work next week. For now, this week, what you do is just get your hands dirty, just install Python, do mission 0. okay, and make sure everything is installed properly. Another thing that you want to do is to do the trainings that is associated with this particular lecture, okay, just for some warm-up, okay, and next week we'll talk some more. Now, to conclude, let me just say something about this class. I'm realistic. Most of you will not become software engineers when you grow up. It means you will learn this class, learn how to write code, but never really write code the rest of your life. So, in view of that, right, one also asks, in view of that, it's probably good to ask yourself, why am I even in this class? Okay, obviously, NUS, for some of you, NUS requires you to do this. For some of you, probably you don't really require this, but you're just trying this out. Now, the point of this class, in my opinion, right, is actually not so much to learn programming, but learning how to learn. Okay, and many of my students have actually commented after taking my class that, frankly, this class helps them exercise the muscles in their brain that they never really existed. The thing that I want to focus on in this class is not so much just learning programming, but going through the process, learning how to persist, learning how to learn, learning something new, okay, and basically cultivating the right habits that will help you for the rest of your studies at NUS. Okay, so with that, I thank you for your time, and I look forward to seeing you on Saturday, okay, when we have our first meeting. I look forward to meeting you and getting to know you over the semester. Okay, take care. See you soon.